My dear people, in this short presentation, we are going to be looking at the various types of pressure measurement devices. I'm just going to introduce them to you all. Yeah, in the previous section, we looked at what is pressure and the equation for measuring pressure at different layers of air of water in a tank, and also at different depths of water, etc. But let us see, instead of using formula, some sort of an equipment that we can use to measure the pressure, shall we? I just want to remind you all of something: compressible and incompressible fluids, my dear people. A compressible fluid is something like a gas or vapor, where when a pressure is being applied on it, what happens is they can reduce the volume of it gets reduced. Do you see? Yeah, volume 1 and volume 2 are different, when otherwise they are very compressible, something like gases and vapor. Whereas a non-compressible or incompressible fluid is something where even if pressure is applied, the volume remains the same. An example would be liquid. Yeah. Okay. In terms of measuring pressure, I asked a group of students about where have they experienced pressure measurement. Yeah. And some of the examples that the students gave were really good, fantastic. Yeah. Some of the things include beverages, meteorological applications, fantastic, power hammer, pneumatic system, blood pressure. Bravo, bravo. Yeah, we really have to measure that. Air conditioner, fantastic, fantastic. Diving equipment, yeah. Air pressure is used with weather stuff, okay. Pressure cooker, water heater in my house, water pressure, coffee machine. Bravo, bravo, yeah. Jet engines, butane tanks, lungs, water cannon, fantastic. Dentist drills, hydraulic, yeah, under pressure from exam. That was really nice, huh? Chamber pressure. And one thing that really impressed me, well, not really impressed me, but impressed the other group of students, is this: when a student has indicated that it's his mom, who's putting him under pressure. I do not know how. I think he's trying to say that his mother measures the pressure that he's under and then gives him some sort of a beverage to calm him down. But then it had like 23 likes. That was really funny. So, my dear people, I just want you to remember that pressure measurement is done everywhere. Yeah. If you think of it, my dear people, this is the equation that we looked at. Pressure equals rho gh, where rho is the density, g is the gravity, and h is the height. Yeah, otherwise the depth from the top. Yeah, so we are just measuring the pressure from this particular surface, from the top of the liquid. But then, yeah, if you think of it, my dear people, the top layer is under a lot of pressure due to atmosphere, is it not? P atmosphere, yes or no? Yeah, it's already under a lot of pressure. So what is the pressure that we are measuring? So the pressure we are measuring because of the liquid in different layers is the so-called gauge pressure. The pressure due to air, yeah, or the atmosphere on the top surface is the atmospheric pressure. And when we add them both together, gauge pressure and atmospheric pressure, we get absolute pressure. Yeah, I'm sure you already know about this from thermodynamics, but I just want you to remember, because this is quite an important thing, my dear people. Again, this is just a pictorial representation. Yeah, gauge pressure is what you see in the different gauges that are attached to pipes, that are attached to tanks, etc. Yeah, there may be flow happening, or it could be attached to a tank. Yeah, it could be attached to a tank, etc. So this is the gauge pressure. Let me just draw it. Wait. Yeah, this could be attached to a tank of water. Yeah, So it just measures what is the pressure in the water. So that would be the gauge pressure. And the atmospheric pressure is because of the air, the entire column of air above our head, yeah, applying a pressure on us. So if you think of it, if you take a column of air exactly above our head, reaching all the way from where we are to the top of the atmosphere, yeah, the total pressure is 1 bar. 1 bar, my dear people, is nothing but 1 into 10 power 5 pascals. Yeah, this is what we usually use, but then the more accurate value would be 1.013 into 10 power 5 newton per meter square, or 1 or pascals. Yeah, it's the same. So I would usually use it as 1 into 10 power 5 pascals. So when we add the gauge pressure and the atmospheric pressure, we end up with the absolute pressure. Yeah, so the absolute pressure that's experienced by the bottom of the tank would be P atmospheric pressure plus P gauge pressure. Yeah, which would be P atmospheric pressure is 1 into 10 power 5 pascals plus the this thing, if this is H, the gauge pressure would be rho g H. Yeah, this would be the absolute pressure that is experienced at the bottom. You know what, my dear people, when I was doing my A levels or GCSE, I do not remember when, or even during the undergraduate first year, I couldn't really understand, not really understand, I couldn't really remember gauge pressure, atmospheric pressure, absolute pressure, etc. I wanted to make it very easy for you all to remember, and also for you to like have it like a mnemonics or whatever they call it. Yeah, so I just thought of this. By the way, uh, when atmospheric pressure is nothing but zero gauge pressure. Yeah, so just to make sure you're aware. So if you think of it, the top of the tank, yeah, the top of the tank here, it experiences zero gauge pressure, otherwise P gauge equals 0 pascal, but then it experiences exactly the atmospheric pressure 1 bar. Yeah, so I wanted to make sure that it's easy for you all to remember. So that's when I was just thinking of how to make it fun for you all to remember. That's when I just I just remembered this song PPAP. Do you remember that it was so very popular during 2016 17 or something like that. Yeah, so I thought I'll just have GPAP for you guys. Do you remember this guy? I think his name is Miko or something. Taro. He was just dancing, saying PPAP. So I thought, well, why don't we just use his method? It's like this: I have a gauge, I have a pressure, gauge pressure. I have the air, I have the pressure, atmospheric pressure, gauge pressure, atmospheric pressure, absolute pressure. I have no idea why I thought of this, but then it was so cool. It was really fun way of easily remembering what is gauge pressure, atmospheric pressure, and absolute pressure. Yeah, thanks, Taro. Exactly, gauge pressure plus atmospheric pressure is absolute pressure. Yeah. Okay. Now, my dear people, one of the equipment that we usually use for measuring pressure is a barometer. Yeah. You might have all seen a barometer. It's just a long tube that is inserted in a tank, or in a yeah, usually in a tank of water or in a glass of water, etc. So what happens is, the water or the liquid that is over there, it will rise to a certain height. Yeah, we know if the pressure, my dear people, look here, it is exactly the same as rho gh. Okay, if the pressure over here, yeah, in this fluid, in this liquid, if the pressure is high, what will happen? The column of water or the column of liquid will rise high, it will go high. If the pressure in this liquid, in this tank is low, the liquid will rise low. Yes or no? Yeah, it is exactly the same, my dear people. So how to calculate the pressure in this tank? We just use this height. So pressure equals rho g hb. Hb is nothing but the barometric height. It is as simple as that. Yeah, so imagine if I use a piston on this tank, yeah, and then I apply pressure, so what will happen? More liquid will go up and the height will increase. Yeah, if I release the piston, what will happen? The liquid level will fall down. It is that simple. Yeah, okay. Usually they used mercury until 2016-17 or something, when the European regulations recommended that mercury not be used. Yeah, so nowadays we use a manometer fluid or a barometer fluid, which is a dense fluid but not mercury. Yeah, okay. So again, it is used to measure the absolute pressure of the atmosphere. The pressure, well, I've just explained it to you guys. Mercury will rise up until the pressure due to it. Otherwise, at this particular point, my dear people, at this particular point, they say that the pressure over here would be equal to the atmospheric pressure. That's why it is staying. Otherwise the atmospheric pressure is otherwise the pressure in the liquid and the atmospheric pressure are in equilibrium. That is why it's just staying over here. Yeah, so they're saying the pressure, I already explained to you, rho GHP. Yeah, and the barometric head is over here. They are saying that the density of mercury is 13,600 kilogram per meter cube. Yeah, so okay, so the mercury is going to rise to a certain height, but instead of mercury, if I use water, tell me, what do you think is going to happen? Water is the density of water, if you remember, density of water is 1000 kilogram per meter cube. Yeah, so if I have the same tank, and then if I have the barometer, yeah, so what do you think is the height to which water is going to rise to? Do you think, if this hb, let us say, due to mercury, if the h due to mercury is 1 meter, yeah, what do you think is the distance to which water will rise up to? This is water. Do you think it will be h due to water will be higher, or will it be lower than 1 meter? What do you think? Let me know. Okay, my dear people, piezometer is another pressure measurement device that we use. Okay, it's used to measure the liquid pressure. So what I thought was, first time I looked at this image of a bulb and a stem going on the top, I was thinking that it actually looks like a bulb. This piezometer actually looks like a bulb. Yeah, and l-shaped, an l-shaped like this, l-shaped tube or a straight tube. But actually, you know what, that is not how it looks like. The piezometer tube is just an L-shaped tube, that's it, nothing more, you know. And you might be asking, well, what is this particular circle all about? It is nothing but, yeah, it is just attached to a tank or a pipe. Yeah, they just drill a hole in the pipe and then they attach this L shape over here. That's it, my dear people. So the side view of this entire diagram, if you think of it, looks like this is the pipe and then they attach the piezometer. Do you see? Yeah. So the piezometer does not have like a circle. It's just, well, it was a bit confusing for me. Perhaps it was not confusing for you guys. Yeah, if it was not confusing for you guys, that's so fantastic. But it was for me when I was little. Yeah. So again, the same thing is happening. Either there is fluid flowing or it is a stagnant liquid. Based on the pressure, what will happen? The fluid will raise and it will go to a certain height. Yeah. And based on the height, again, my dear people, yeah, we can use the formula P equals rho g h. That's it. It is as simple as that. If the pressure is higher, h, otherwise the height to which the liquid will rise will be higher. I have actually made a fun video explaining and also showing you guys, yeah, in the fluids lab. I went to the fluids lab for you guys, made some short videos on how pressure is measured using piezometers. Yeah, have a look at that, my dear people. Oh yeah, again they're saying that absolute pressure is atmospheric pressure plus the gauge pressure. Yeah, here we come to the YouTube manometer. Yeah, this is quite an interesting aspect, my dear people. Yeah, look at this. A YouTube manometer is nothing but, instead of a L shape, it is a U shaped tube. That's it. Okay. And this is where we attach to a tank, or instead of a tank, you can, okay, wait, I'll show you. It's just a U shaped thing. Yeah, U shaped tube. And then here you can actually, it doesn't look like a human face, does it? Yeah, you can actually blow air, yeah, and then measure what is the pressure that you are exerting. So usually it is filled with water or some manometer fluid or mercury. Nowadays not mercury anymore. Yeah, when you blow air, what are you doing? You are increasing the pressure. So what do you think will happen? This fluid will go down and this fluid will go up. Yes. So the difference in this height, my dear people, the difference in the height, similarly, if I'm blowing air here, what happens? This layer will go down and this will go up. Usually if you think, yeah, if you think of it, this is where we attach, the fluid will be in the same level. Yes, that is how it is, because both of them are subjected to atmospheric pressure. When there is an increase in pressure here, what will happen? This will go down and this will go up. And the difference in the height, my dear people, the difference in the height is hp. Yeah, that's it. And we use the same formula, P equals rho gh. Do you see? Yeah, so the gauge pressure is rho GHP. The absolute pressure would be atmospheric pressure plus rho GHP. So now my question to you all is this. Okay, okay, let me ask you. So instead of, like, what is it? Instead of blowing air inside the tube, if I'm sucking air out, yeah, what do you think will happen? Huh? So the tube is like this, the manometer, yeah, and then the liquid are at the same level. Now instead of blowing air, I'm sucking air out. So what do you think will happen? Huh? Exactly, this area, this tube will have a low pressure and this will have a high pressure. So this will just change like this. Let me just draw it in a different color. So the difference in height between this would be hp. So the formula would be rho g hp. Actually, I have made a fun video for you guys. Yeah, I've made a fun video for you guys on using manometer. Manometer doesn't have to be any equipment. It can be a simple tube. I have demonstrated this to you guys, yeah, and also I've uploaded a video for you. I will put that video in the description so you can have a look at that. Yeah, here the same thing, when air is being sucked out, this level will go up and this will go down. So the difference in the height is this particular thing. Do you guys remember in Bernoulli's equation there were a couple of problems in which the pressure was negative, and then I asked you guys why is it, and also I gave you an explanation. It is because the gauge pressure is negative. Yeah, exactly the same, my dear people. Here the gauge pressure is negative. Do you see? Because of low pressure, because air is being sucked out. Yeah, what is happening, there is an area of low pressure compared to the atmospheric pressure. Yeah, that is why gauge pressure is in the negative. Yeah. Well, more than that, usually these days they just use the Borden pressure gauge. There's a video, it says that it cannot be played. Sorry guys, have a look at what's Borden pressure gauge. Yeah, you'd really like it. Well, I'd like to finish this particular presentation by thanking all of you. Hope you enjoyed it, and in the next section we'll look at buoyancy. Bravo.